Hello students, today we will going to study about sets, chapter 1 of class 11th. In the previous session, we have already covered subsets, power set and universal set. In this session, we will be covering Venn diagram, operation on sets, complement of a set and some practical questions on union and intersection of sets. So let us first study about what is Venn diagram. Most of the relationships between sets can be represented through diagrams, and these diagrams are known as Venn diagrams. This Venn diagram is named after English logician named John Venn. These diagrams consist of rectangles and closed curves, usually circles. The universal set is usually represented by a rectangle and the subsets by circles. As you can see in this picture, here you can see this rectangle is representing a universal set U, and the subsets of U are represented by these circles, which are set A and set B. So what are elements in the set U, universal set? All the numbers which are coming inside this rectangle. They are 1, 2 up till 10. What are the elements of the set A? All the numbers inside the circular region of this set A, which are 2, 4, 6, 8 and 10. And what are the members of the set B? 2, 4 and 6. Understood? You may also see that this circular part which is representing B is inside A, which shows that B is a subset of A. So, now let us move on to the other topic, which is operation on sets. Whenever we have to find a new number, we operate two numbers. For example, addition operation, when we add 2 plus 3, we get a new number which is 5. Similarly, if we want to find a new set, we perform different operations. And what these operations are? Let us study about them. The first operation that we are going to study is union of sets. What does it say? The union of two sets A and B is the set which consists of all the elements which are in A as well as in B. The common elements are taken only once. Symbolically, you may see that A union B is equal to the set of all those elements where the element is belonging in A or in B. Okay? So, let us take one example on it as well. If I have two sets A and B, A consists of two elements 1 and 2, B consists of two elements 2 and 3. If I say what will be A union B, what you will going to write? Each and every element of A and B. So, 1, 2, 3. Remember, 2 is common to both A as well as B. So, common elements has to be written only once. So, A union B is equal to a set which consists of 3 elements 1, 2 and 3. Symbolically, the notation for union, you can see that it is like letter U. It is representing union. According to the diagrammatic representation, we can also represent union as this, which you can see in this image. What it is representing? This rectangular part is representing the universal set U. Also, we have two sets A and B. So, we have taken two circles representing set A as well as set B. To represent union, you may see we have taken these red lines, and these red lines, the portion which are having these red lines is representing union part. Okay? Understood? So let us see some properties on union. So properties of the operation on union are as follows. The first property is the commutative property or the commutative law. What does it say? The order of the sets does not matter. That means if I A union with B and take B union with A, then the answer will comes out to be the same. Let us take some practical values in it and verify ourselves. We already know A union B was coming out to be 1, 2 and 3. So let us find out B union A. You may see on finding out B union A, B is 2 and 3, adding the distinct elements that are in A which are not in B. 2 is already there in B, so we will only going to add 1 in it. Now it is clear A union B is equal to B union A. So this shows that the operation union satisfy commutative law. Next property that we are studying is associative law. What does it say? That if we first associate A union with B, that is if we are taking A union with B and then the answer with C. Again, if we are taking A union B and the union of the answer with C, it will be same if we first take union of B and C and then union of the answer with A. So let us verify. A, B. We already know that A union B. So here we are finding out LHS part. A union B was 1, 2 and 3. Now taking the union of A union B with C. It is 1, 2, 3, 4 and 5. Okay. So we have found it out the LHS part. Now we will going to find the RHS part. We have to first find B union C. What is B union C? It is 1, 2, 3, 4 and 5. And A union B union C. You may see A is consisting of elements 1 and 2 and 1 and 2 are already present in B union C. So B union C will be the answer for it, that is the elements which are there in A union B union C is 1, 2, 3, 4 and 5. Now observe LHS and RHS. Are they equal? Yes, they are equal. So this property, this law is associative law. Now the next law is the law of identity element. Very interesting law. A is any set. If we union with an empty set, what will be the answer? Empty set does not have any elements. So we cannot add any element to A. So what will be the result? It will be the same set, that is set A. So here it is. Okay. Now the next law, which is the idempotent law. What does it say? When I operate a set with itself, A union A. We have taken A union with A, that means we have to add all the elements which are there in the other set, but that is the same set. So what will be the answer? There is no new element, that is we are adding. As you can see in this case, let us take an example. A union A, 1, 2 union 1, 2. Is there any other element that we will going to add in this? No. answer will be same, that is 1, 2. So, A union A is coming out to be the set itself. Now, last property, which is law of universal. Simple. U and A, and we know A is a subset of U. That means every element of A will already be in U. Okay? So, if I finding U union A, the answer will be U only. Okay? Now, let us see another operation. What it is? Intersection of sets. And what does it define? The intersection of sets A and B is the set of all those elements which are common to both A and B. Common to both the sets A and B. Symbolically, A intersection B is equal to all those elements where this X is belonging to set A and set B. Understood? Again, let us find what is A intersection B if the two sets are given to us. It is an old example. A consisting of two elements 1 and 2. B also consists of two elements 2 and 3. What we have to see in this? The common elements. Only one element which is common in both, which is 2. So, A intersection B is a singleton set where 2 is the element of A intersection B. Notice, this is representing the notation of intersection, which is, we can say, is looking like an inverted U. Again, intersection, if we represent it in Venn diagram, rectangular part representing the U, that is universal set. Two sets are there. So, this is representing set A, this is representing set B. You may see there is some common part in these two circles, and this common part is shaded with pink color, and this pink color, the common part, is representing A intersection B. So, let us take some properties on this operation. First property, same, commutative law. It is easy, we have already discussed what is commutative law. Second also, associative law. It is easy to verify. Verify yourself. You can verify by using some particular values for the sets as well. Law of identity, A intersection with an empty set. Again, here you may see A intersection with empty. Empty set does not have any elements. That means set A and empty set does not have any common elements. Will they have any common elements? No. So, what will be the answer? Empty set. Here it is. Now, the next property, idempotent law. Same, if we operate set with itself, what will be the answer? A intersection with A. Let us take some practical values. Here 1 and 2. So, if I have to find A intersection A, that means this is what I have to find. It is visible. How many elements are common? Each and every element is common. So, the answer is the same set A. Okay? Now, the law of U intersection A, where A is the subset of U. That means every element of A is a member of U. That also means that every element of A is common element. And so, what will be the answer? U intersection A will be the set A. Students, let us see the last property, which is distributive property. We also say it as distributive law. What does it say? If we first take union of B and C and then take the intersection with A, that will be equal to the union of A intersection B and A intersection C. Let us verify this by example. LHS, first we have to find B union C. What it is? 1, 2, 3, 4 and 5. Now, we have to take intersection of A with B union C. A 1, 2, 1, 2. So, intersection is a set which is consisting of two elements 1 and 2. RHS, A intersection B. How many elements are common in A and B? 1. B, A intersection C. How many elements are common in A and C? 1. That is element 1. Now, finding the union of the two, what we are getting? A set consisting of two elements and the elements are 1 and 2. Here you can see LHS and RHS, both are equal. This verifies our distributive property. We can also verify this distributive property through Venn diagram. Let us see. Here, this part is representing your LHS part, B union C. So, all this shaded portion is representing B union C. Now, we have to take the intersection with A. So, the part which is common to B union C is this. So, we have shaded these two parts, and this shaded region is representing A intersection B union C. Now, see the RHS part. In this, first we have to find A intersection B and A intersection C. We have three sets A, B and C. A intersection B is the common portion between A and B. A intersection C is the common portion between A and C. And we have to take the union of it. So, we colored both the parts, as you can see in this image. Now, observe these two images are same and hence they are verifying the distributive law. Now, students, let us take one more operation. The next operation is difference of sets. The difference of a set A and B in this order. Notice this word order, we will going to see it later, is the set of elements which belongs to A but not in B. As the name suggests, it is a difference. Symbolically, A minus B, it is representing all those elements which are in A but not in B. Now, why have I have said order? See this case. First, let us take an example and then observe why this order is important. A and B, we have taken two sets. If I say find it out A minus B, what will be the answer? I have to eliminate all those members of B which are coming in A. So, answer will be 1. Okay. Now, if I take B minus A, I have to take all those elements which are in B but not in A. So, here the answer becomes 3, means a singleton set which consists of an element 3. Now observe students, A minus B and B minus A, both are giving us different answers, different sets, and that is why order is important. So if I say A difference B, that means we are taking A minus B, and if we are taking B difference A, we are taking B minus A, because if we change the order, the answer will also change. Okay? Here this note, A minus B is not equal to B minus A, which also says the difference operation does not satisfy commutative law. Okay? Now see the representation in the Venn diagram. Universal set, this set is A, this set is B. This part was A intersection B, the common part. You may see, if I remove the common part from the set A, what will be there? What is left? This portion, and this portion is representing all those elements which are in A but not in B. So yes, this portion is representing A minus B, and the other similarly representing B minus A. Okay? Now let us take another operation, complement of a set. And what does it say? If U is a universal set, A is a subset of U, then the complement of a set A is the set of all those elements which are in U but not in A. Yes, it looks like difference, and this is how we can write it as A complement is equal to U difference A. Symbolically, it writes the same, A complement, which is denoted by a dash sign, A dash, or we can write U minus A, is equal to all those numbers which are in U but not in A. If I say find the complement of A, what will be the answer if U is given to you? A complement will be the set of all those elements which are in U but not in A. So we will only write all those elements which are there in U but not in A. So elements are 1 and 3. If I say represent in the Venn diagram, how you will going to represent? A elements are 2 and 3, 2 and 3. No, it is 2 and 4. So 2 and 4. This is representing set A. This is representing universal. This rectangle is representing universal set. So A complement are those elements which are not in A. So it will be representing somewhere here. You can write it anywhere. So this is how we are representing. So the complement part is representing the portion which is coming outside this circular region, but inside this rectangular part. Okay? Now let us move further. Here you can see properties of complement of a set. The first properties, we can see the complement law. Easy. A union A complement. We will going to understand this by Venn diagram. This is U, this is a set A, and if this portion is representing A, obviously this part is representing A complement. There is nothing common in the two. So when we take union of the two sets, we get the full universal set. So this is the complement law. Similarly, just now I have said that does not have anything common. That means if I take A intersection A complement, it is a empty set. The next property is very important, De Morgan's law. And what does it say? The complement of the union of two sets is equal to intersection of their respective complements. Let us verify one with an example and other you may do by yourself. Here A union B is 1, 2 and 3. So, what is A union B complement? If universal set is U, it is 4, 5 and 6. Now, see the RHS part, this is the LHS part. RHS, first we have to find A complement. So, A complement is giving us 3, 4, 5 and 6. B complement giving us 1, 4, 5 and 6. Now, what we have to take? The intersection between the two. It is 4, 5 and 6. Now, you may see that we have verified LHS is equal to RHS. Similarly, you can see for other as well. Now, the law of double complementation. What does it say? If I take the complement of a set, what will be the answer? What will be the set? It will be the same set A. Again, you can verify, it is very easy and interesting. The last one, law of empty set and a universal set. Let us see with the help of Venn diagram here itself. This is representing U. Empty set, that means nothing is there. If I take the complement of it, that means every element which we have taken in the universal set will be the answer. So, the full universal set is the complement of an empty set. Again, similar, the vice versa for it. If I take the universal, what? The complement of the universal set, if I eliminate each and every element, then nothing is left and I will get an empty set. So, complement of a universal set is empty set. Hope you have understood, students. Now, let us move further. You may observe the following remarks, what we have learnt up till now. If B is a subset of A, then A union B is equal to A. If B is a subset of A, then A intersection B is B. If A and B are two sets and the intersection between the two is empty, then the two sets are said to be disjoint sets. Also, we have seen that A minus B, A intersection B and B minus A all are disjoint sets. Lastly, if A is a subset of universal set U, then the complement of it will also be a subset of U. Now, let us see some formula which is very important for the practical questions. First one is representing the number of elements in A union B is equal to number of elements in A, number of elements in B and number of minus the number of elements which are common to both. As you can see, this is a universal set A and B. In union, the common element is repeated twice. We are taking 2 times. So, we have to eliminate 1. So, here number of elements A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. If we have 3 sets, then N A union B union C, where N is representing the number of elements in this set, is equal to number of elements in A plus number of elements in B, number of elements in C, minus the common elements. What it is? Minus the number of elements in A intersection C, minus the number of elements which are common in A and B, so A intersection B, minus the number of elements which are in B intersection C, plus the number of elements which are common in all the 3 sets. which is A intersection B intersection C. Now students, let us take some questions based on them. First question says, if X and Y are two sets and X union Y has 50 elements, that means NX union Y is given us to be 50. X has 28 elements, Y has 32 elements. So, how many elements are there in X intersection Y? That means we have to find the elements in X intersection Y. Previously, just now we have seen a formula which is saying NX union Y is equal to NX plus NY minus NX intersection Y. If I put values in this equation, what will I get? It is 50 is equal to 28 plus 32 minus NX intersection Y. On solving it, we may see that NX intersection Y is coming out to be 60 minus 50, which is equal to 10. So, how many elements are common in X and Y? 10 elements. Hope you have understood how you have to use that particular formula. So, let us take one more question. It states, a market research group conducted a survey of 1000 consumers and reported that 720 consumers like product A, 450 consumers like product B. What is the least that must have like both products? Okay? Least which have like both products. So, what is the minimum number of liked products we have to know? Let us see the answer. Here, let us take U be the set of all those consumers which are questioned, S be the set of consumers who like product A, T be the set of consumers who like product B. So, according to the question, number of elements in U is 1000, number of elements in set S 720 and number of elements in the set T is 450. Now, we already know this expression. If we put the value in the given expression, what we will get? You may see that number of elements in S union T is equal to 1170 minus the number of elements which are common in S and T. You may notice that whenever the number of elements in S union T is maximum, the number of elements in S intersection T will be least. And what will be the maximum value of number of elements in S union T? How many consumers are questioned? 1000. Number of elements in the universal set is 1000. That means the number of elements in S union T will always be less than equal to 1000. So, we know the maximum value. Now, what we can see that this expression will always be less than equal to 1000. We find this inequality, and on solving it, we may find that the number of elements in S intersection T will always be greater than or equal to 170. What does that mean? That the least number of consumers who like both the product is 170. So, these are some of the practical questions that we have taken on union and intersection. Now students, in this session, you may observe we have studied Venn diagram, operations on sets, complement of a set and some practical questions on union and intersection. Hope you have understood and enjoyed this session. Thank you.